Well, good evening, everybody, and welcome to Roundtable 9 with Brenda von Ahsen on Quantum Mechanics Truth, a response video to Rightthehand, with a possibility of a few extra subjects to cover. Brenda, are you there? Hello, if you want to take yourself off mute there, Brenda.
Oh, can you hear me?
Well, I can hear you now. How are you?
Great, great. So I wanted to begin by apologizing to everybody. It was entirely my fault. I just didn't know how to properly operate Skype, and I screwed up and missed the call.
No worries. No worries, Brenda. At the end of the day, it sort of worked in my favour, to be fair, as well. You know, I could have... just with you not being able to be contacted for over 24 hours and with 30 minutes just to go, I decided, you know what, I could do with the evening off anyway. So it worked for the best anyway. I had my brother over. I hadn't actually seen him for coming up to 2 years now, so he landed out of the blue. But I was still prepared to do the show, as you know, through the emails that I sent. But obviously with with no response, it was just like, okay, I could actually, this works for the best.
Yes, I did have computer difficulties and was not, for the full time, did not have email up because I have some difficulties with my system.
Okie dokie. Well, are you prepared to share your screen right now and I can get this show on the road?
Okie dokie. So,
just going to wait for you to share the screen.
Does that work? Share the screen and display. Is that showing up correctly?
It is. Yep, we can see that. I'll put you on now. There we go. The floor's yours. I'll be silent until you finish your presentation.
Oh, okay. So I wanted to have a response to Rightthehand, and I wanted to cover a few things about that and to also address a few other issues that seem to be outstanding there in the community. And here's a list of things about popular views about quantum mechanics. All of these are either outright wrong or partly true and partly wrong. Quantum mechanics is weird. Quantum objects can be both waves and particles, particle-wave duality. Quantum objects can be in more than one state at once, superposition. You can't simultaneously know exactly two properties of a quantum object. Quantum objects can affect one another instantly over large distances. And you can never measure anything without disturbing it. These are all either false or partly true and partly wrong. So I wanted to address some of the things that Rightthehand said. Rightthehand gave what was really just more emotion rather than reasoning. He just simply declared that a lot of things simply didn't make sense or were wrong and stupid. And I don't think that that is fair to John, Quantum Eraser. It's not fair to quantum mechanics or to physics either. Rightthehand said that physics is the study of physical objects, which is true. But he then said that mathematics is non-physical and therefore concluded that mathematics is not a part of physics or science, and that is simply false. Math is the language that we use in order to study the physical world. The application of math to the physical world is not invalidated because math is a concept. We are allowed to use concepts and numbers and mathematical formulas to describe the world around us. And this is true whether the Earth is flat or not flat. It doesn't matter. The science is still the same. Another issue that Rightthehand had was with the observer effect, which he simply ridiculed and engaged in name calling. The observer effect is a very real thing. When we observe things, when we measure things, we necessarily have to interact with them. And by interacting with them, we change them. So if you want to measure the air pressure in a tire, you put a little tire pressure gauge onto the stem, you release a small amount of air pressure. You have changed the air pressure in that tire by the sheer act of measuring it. The observer effect is very real, but it's inconsequential for most things. However, at the quantum level, it can have a real effect in things. It, however, should not be confused with the uncertainty principle in quantum mechanics, which is very different from the observer effect. The uncertainty principle states that there simply is no such thing as a particle's position and velocity before it is measured. Another issue was superposition. Rightthehand seemed to be confusing superposition with a diffraction limit. Superposition has nothing to do with how things appear at a distance. It is simply the cumulative sum of the parts of a system into the whole. So if you have a multiple number of waves, say sound waves, the superposition of those waves will result in a waveform that is the addition and of the crests and the subtraction of the troughs into one single waveform, which would be the superposition of all the other waveforms. That's all that superposition is. It isn't magic. Quantum mechanics is not magic. Quantum states are simply, in the same way, the outcome of all possible measurements on a system. That's all it is. It isn't terribly difficult. A quantum state is simply the possible, probabilistic measurements of a system. And we can use probability to describe a lot of things in science, both classical science and quantum mechanics. Another issue that Rightthehand had was wave-particle duality. Science is not just determining a cause, but it can also be quantifying, categorizing, and describing the natural world. So waves and particles are ways of describing and categorizing the world. For example, in a sense, everything is a wave, and in a sense, things have a particle-like nature. So light is both a particle and a wave. In a sense, it depends. It isn't that it changes its nature, but how we perceive it depends on how we measure it, right? And also, science is not simply determining causes. Science is also categorizing and systematizing the world around us. So a biologist who goes out and collects plants or beetles or butterflies and then brings them back and typifies them, quantifies them, studies them, and puts them into what he thinks are proper categories, that is also doing science. The same is true for chemistry. With chemistry, we take elements and we categorize them into what we consider to be a system that makes sense to us. And then we test those systems against reality. Still, another point that Rightthehand brought up was his confusion about whether light is composed of different frequencies. It is. And we can know that light is composed of different frequencies because when light passes through a prism, the prism will separate the white light, into its component wavelengths, because due to the nature of a prism, different frequencies will travel at different speeds and pass through the prism at different angles, and this results in the familiar rainbow pattern that we see, and that is how we can know that light is composed of different frequencies of light, because we can break it up into its component frequencies. It's not hard to do. Still another, I'm sorry if this is somewhat boring to people. I'm not very accustomed to this. I'm just running through a list. The light from lasers are perfectly natural. Even though the laser is man-made, the light that comes out of a laser is natural. It is a natural phenomenon. The light is not made by God. It's not made by man. Light is created by accelerating charges. So that is still another confusion. This is part of the general confusion of the flat Earth groups who think that natural means not man-made, and that is false. That's not what natural means. It simply means part of our physical world. We can know, for instance, that light is a wave because when light passes through a double slit, it produces a diffraction pattern at the screen at the other end. And the only thing that can produce a diffraction pattern is a wave. Objects cannot produce waves because objects cannot interfere with itself. Light can interfere with itself, so it must be a wave. The usual reply to this is to cite the photoelectric effect, and that does not show that light is an object. It shows that it is a particle, and particles are not objects. It is a highly compressed wave packet, a localized wave form. So, and light is quantized. That's what the photoelectric effect shows, that light is not, and all energy, and in fact everything in the universe, is composed of waves that are quantized. They are not continuous. So if you don't do not shine enough energy on the photoelectric material, you will never get a particle. It's only once the energy of the light falling on the photoelectric material is sufficiently energetic to release a photon, that is the only time when you'll get that. Anything less than that amount will not register at all, right? So there is a sort of a granular quality to reality, and everything is composed of particles, but particles are not objects. Particles are composed of waves. I don't know if people can see these. Here is a wave equation for a free particle. This is a particle, and as you can see, it is composed of a wave. The equation there describes this particular particle. This next shot shows a more realistic or ordinary situation where it is compressed along the axis. It is still, however, a wave, even though it has very particle-like properties, and it will interact with other things like a particle under certain situations. But because it is composed, it is in fact a wave, and is described by the previous equation. It will in fact behave as a wave under certain circumstances, depending on those circumstances. And in other circumstances, this will act as a particle. This is wave-particle duality right here. It is not mysterious. It is not a violation of logic. It does not justify us in engaging in quantum woo or mysticism of any kind. Light is a wave that has a particle-like nature to it, and how it interacts with the world depends on the circumstances of that interaction. Reality does not depend on observers. Reality would exist whether we exist or not. We know light can, okay, I'm going to go to, apologies, I'm going to go through quantum particles do not have wave-object duality. They are never objects. They are always waves. And quantum particles always obey quantum mechanics. When the quantum collapse occurs, it does not stop being quantum and become classical. It's always quantum. And quantum mechanics does not require conscious observer. Observation is simply measurement or interaction. Anytime that any particle interacts with any other particle or any instrument or any material whatsoever that is an interaction, that is a measurement, it's an observation. That's what that means. Let me see. Okay, I feel that I've sufficiently replied to Rightthehand. I felt that his presentation was unfair to John Quantum Eraser. It was mostly a diatribe, a rant, which I guess is okay. If you want to rant, that's fine. But he did not, he just simply expressed anger, incredulity, and hostility, and had no arguments and just nothing to back up his claims. His claims were entirely false, not based on any science whatsoever. So I want to address now a certain problem that has been present in the flat Earth community for quite some time. It's the confusion about pressure. Pressure is force per area, per unit volume. The pressure does not require a container, although a container can certainly have pressure exerted upon it. It is not a necessary requirement. The necessary antecedent of pressure is not a container. That is a lie. It is a deliberate lie, because the people who are telling you this lie are doing so knowingly and deliberately. Pressure is force over area. Any area, anything with a surface area can experience pressure. And we know that because the force applied by pressure is simply energy density. It's joules per cubic meter. It is simply the average kinetic energy, and here we see the individual molecules of the atmosphere, of the air, or of a gas. They all have kinetic energy, and they are bouncing around. And they will exert pressure on any surface, whether it's in a container or not in a container. They will exert pressure. So a plate suspended in the air will experience pressure applied to its surface in proportion to the previous formula, in proportion to the force applied to it and the area, the surface area of the plate. That is simply what it is. There's a lot of confusions in the flat Earth community about what science actually is. And they confuse natural, like, say, for instance, the difference between something that is man-made and something that is not man-made, and natural as used in science. It's typically used colloquially as to describe things that were not made by humans. But in science, natural has a broader meaning. Within science, the term natural refers to any element of the physical universe, whether made by humans or not. And that includes man-made instruments, man-made experiments, man-made forces and phenomenon. Anything that includes matter, that has forces that act on matter, energy, anything on the biological world, the human world, or human society, and the products of that society. So we wouldn't necessarily think of them as natural in the everyday sense of the word, but science can still study those things. We can study human society as a natural phenomenon because that is what it is. It is part of the natural world. People in the chat quite often make fun of me for stating that a shoe is a phenomenon. The concept I was trying to get across is this distinction first made by Immanuel Kant, which is the phenomenal-noumenal distinction, the distinction between our appearances and the things in themselves. A phenomenon is any perception whatsoever. Noumenon are the things in themselves. So if I see a shoe, I see the phenomenon called a shoe. I do not see the shoe in itself. And in fact, according to Immanuel Kant, we can never know the thing in itself. We can only know phenomenal appearances. So if I perceive a shoe, or what I believe to be a shoe, it might not be a shoe. It might be a sculpture of a shoe that has been painted to appear as though as a shoe. It could be paper mache. It could be CGI. It could be anything. It's only after I test it and see that, yes, it is indeed made of leather with a synthetic sole, with cotton top or cloth top and laces that are real. Only then can I conclude that this is what we call a shoe. I'm still dealing with appearances, with perceptions. And that's all that we have as beings in this world. We only have access to phenomenology. And phenomenology is the study of appearances. It is the world that science studies. It studies the phenomenon of reality. We have no access, according to Kant, to the noumenon, which is the things in and of themselves as they are in themselves. So this is a misunderstanding by people of reality. I wanted also to address some things. This is from John Quantum Eraser, and it shows the lies, and it is a lie. It is a deliberate, malicious lie by Nathan and John to claim that a container does not need to be sealed. Here he is saying, if the container is not sealed, the gas will escape. Because previously, that's what they had claimed, that in order for you to have gas pressure, you must have a sealed container. And then other globe earthers showed that this was not necessary, that it is not necessary to have gas pressure you can't have gas pressure without a sealed container. You can. And this shows the lie that has been promoted by Nathan and John, because they want to promote a religious ideology, which is what they believe in. Still another issue that has come up has been the issue about whether or not gravity is a force or not. This is also another deliberate lie on the part of Nathan and John. They will often say that gravity is, and this is a direct quote, one that they did, but John left out the red underline just. And so that is a lie of omission. We know that gravity is not just a force, right? When we think of gravity, we typically think of it as a force between masses. When you step on a scale, for example, the number on the scale represents the pull of the Earth's gravity on your mass, giving you weight. It is easy to imagine gravitational force of the sun holding planets in their orbits, or the gravitational pull of a black hole. Forces are easy to understand as pushes and pulls. But today, we now understand that gravity is not just a force. It is part of a larger, more complex phenomenon described by the theory of general relativity. And while general relativity is elegant, it is a departure from the idea of gravity as a force. Nevertheless, as we have said, it can be described as a force. When gravitational field is weak and the sources are moving slowly compared to the speed of light, general relativity reduces to Newtonian gravity. Newtonian gravity is a special case, a subset, a case of general relativity. So it is not wrong within our world, where we are not moving close to the speed of light and where the gravitational field around us is not anywhere close to that of a black hole for us to use Newton's original formulas, because they work within this general prescribed area, simply because it is a special case. For most applications, gravity is best explained by Newton's law of gravitation, which states that gravity exists as attraction between two bodies. The strength of that calculation, that can be calculated mathematically, where the attractive force is proportional to the product of the masses and inversely proportional to the square of the distance between them. This is another example of one of John Quantum Eraser's lies, and it's a deliberate, malicious lie of omission. He did not mention the part that I have underlined on here above. He simply addressed the part above. According to this theory, gravity is not a force, which is true. It is not. But it can be described that way within our world, within our circumstances. Okay. I think that is enough for him. I want to also address how we can know things. Certain people, I think Slick has these issues, and a lot of people have these issues. We have in our minds feelings and thoughts. Feelings are not thoughts, and thoughts are not feelings. So a thought is any kind of mental content. A belief is a kind of thought, and a belief is something that we hold to be true. So if I believe that the moon is a hologram, I believe it is true that the moon is a hologram. It doesn't make it true, however. Believing something does not make something true, right? So knowledge, then we have to introduce the concept of knowledge. Knowledge is a belief. All of science is a belief. Everything that we think about things are beliefs, the things that we hold to be true. Knowledge is a belief that is in fact true. So if I believe that the moon is a hologram, I cannot claim knowledge, because I cannot show that it is in fact true that the moon is a hologram. I have to have a way of justifying my knowledge. There has to be a way for me to demonstrate that it is not simply a thought in my head, but is in fact a fact about the world that does not depend on my thoughts. So if I believe that Mount Everest is 26,000 feet above sea level, I can believe that, and it is true that I can believe that, because I can measure how high it is above sea level, because there is a system for measuring things. So we can use trigonometry and observations to calculate the size of objects, even if we can't touch them. I do not have to travel to the peak of Mount Everest to measure its height. I can simply use observations. Let me see if there's anything else that I wanted to cover. This is an interference problem, interference pattern. This is what light is. Light is a wave. It is not a particle. Here is what is a hydrogen atom. The part in the middle is the nucleus. The electron occupies a standing wave around the electron, right? It is not a particle that is orbiting a nucleus. It is a wave that is in a standing wave pattern around the electron, and it maintains that behavior because of the nature of the forces involved. I don't know if I need to go through that, and I've covered that, and I don't think that I need to cover anything else. I think I have covered everything. Thank you, Ranty. I will stop sharing my screen, and I am done.
No worries, Brenda. No worries. Thank you very much. Caught me a little bit by surprise there. You defended John on the one hand and then you slammed him with another. Very interesting, very interesting. I'm sure he might have something to say about that. But stay with us, guys, in the chat. If you want to stick yourself on mute for 5 minutes, Brenda will play a little bit of music. And when we come back, I am sure we'll have plenty of questions from the chat. So now's your time, guys. You've heard the presentation. If there's anything you want to ask Brenda when we return, put the questions in the side chat, either direct it to Brenda or direct it to me. You could also write it in capitals with question so that I can actually see it, because quite often a lot of comments I won't know whether they're a question or responding to someone else, so please make them concise. In the meantime, let's have a little bit of music and we'll see you shortly.
Since the beginning of mankind, people thought the earth was flat. A giant disk underneath a firmament dome. The earth was the center of the universe. 500 years ago, science told us we live on a globe. A spinning ball shot into infinite space. They want us to believe that we are nothing but random stardust. Meaningless, but they're wrong. They lie. Wake up. The earth is flat. The earth is flat. Is a hoax. We never landed on the moon. Do you believe we're living on a rotating ball flying through space at thousands of miles per hour? Where is the curvature? Where? They control our minds. They control our thoughts. They control everything. Think twice. Think again. Wake up. The earth is flat.
Brenda, are you there still? You can take yourself off mute now. Hello?
Oops, there we go.
There we go.
Yes, I'm here.
Okay, so we have a question from Crow XE. Now, he did a presentation last week. So he wants to ask you a question. It says, regarding natural and man-made, isn't there elements or materials that are made in reactors and don't exist in nature? How do we classify those?
The fact that they exist at all means that they exist in nature, because nature is just the natural world. So the fact that we can come up with chairs don't exist in nature. We can create a chair by assembling sticks of wood, but chairs don't exist in nature. And so an element is just a combination of neutrons, protons, and electrons. And the fact that we can make new combinations doesn't mean they don't exist in nature. Nature is simply the natural world. It's just everything. If it exists in the natural world.
Okay, so there's been a couple of questions from different people asking the same one, which is, Brenda, how is light generated?
Light is generated by accelerating charges. That's how, for example, that's how radio waves work. You send an electrical charge down an antenna. That charge is accelerating, and it generates a radio wave, which is electromagnetic radiation, and all light is simply electromagnetic radiation. Moving charges create electromagnetic radiation, which is light.
Okay, so a statement from Ryan Q. Vincent, who says, general relativity is an extension of special relativity, and special relativity can be shown to be false in the real world. What would you say to that?
That's not true. Special relativity is one of the most corroborated physical theories of all time. There have been literally thousands of experiments that have confirmed over and over the claims and the predictions made by special relativity. If he wants to refute special relativity, I would suggest he compose his paper, submit it to Nature, and collect his Nobel Prize.
Okay, question from Brian Leake. Brenda, why has quantum mechanics failed to detect gravity?
Well, we have detected gravity. With the LIGO experiment, we can detect gravity waves. So we don't know exactly what gravity is. It is a wave, because we have detected it. We don't know how it works. There are theories about how it works that would integrate it within quantum mechanics, but it is an ongoing product of research. One of the things that people will often say is that we know that general relativity must be wrong because it conflicts with quantum mechanics, but we don't know how it is wrong. But nevertheless, even though general relativity must be wrong, the solution will still have to preserve all the observations we have made so far. So just as relativity confirmed and contained the formulas of Newtonian mechanics, quantum gravity will also be able to account for the descriptions of relativity when we have it. But we don't have it now. We don't know.
Okay, we have another question from Anthony Burrows, who asks, if light is a wave, like a radio wave, why does it bounce off walls?
It doesn't bounce off walls. It gets absorbed and then re-emitted. The light will strike the atoms in the wall. It will be absorbed and then re-emitted. So it doesn't actually bounce.
Okay, well, a question from Daniel. Quantum Eraser often says photons are neither electric nor magnetic. Do you agree?
Neither electric. Well, photons are light, and light is a wave. It is a disturbance in the electromagnetic field. So they are a phenomenon of electromagnetism. Everywhere in space, there's something called the electromagnetic field, right? And so a photon is a local disturbance in the electromagnetic field, and it appears as a particle because the energies of that electromagnetic field are quantized. They're not continuous. So you can't have just a little bit of a disturbance. You have to have just the right amount. And so that is what a photon is it is a disturbance of the electromagnetic field. I don't know what he means by saying it's not electric nor magnetic. It's electromagnetic. If that's what he means, then he's correct. But if he means something else, then he's not correct. So I'm unclear of what exactly John said. I didn't hear him say it, so I don't know exactly what he said.
That's fair enough. We have another question. Brenda, does gravity exist in light?
No, gravity is not light.
No, does it exist
There,
in light?
no.
Okay.
There are four fundamental forces: gravity, the strong nuclear force, the weak nuclear force, and electromagnetism. And that's it. Those are the four fundamental forces from which everything in the universe is composed. There is nothing else.
Okay, from Super Dave, where does energy come from?
Energy simply exists. This universe exists. We don't know where the universe came from or how it came to be. There's the Big Bang, but the Big Bang doesn't, the theories about the Big Bang do not tell us the origin of the Big Bang. It takes us to time t minus 10 to the 34th second, and we can't get to time equals 0. So we don't know why the universe exists, but that's where all energy, all matter, and everything in the universe came from. We just don't know. Our current theories do not tell us how the universe came to be. We don't know. There are theories to explain for it that would explain it by natural phenomenon, but we don't know. We simply don't know. There's a lot of things that science simply doesn't know, and so we just say, don't know.
Okay, so slightly off topic, but from Carl Stenbach, who asks, and he says this is a serious question, so what qualifies yourself, Brenda, to declare these things as fact? And why does Brenda use the word we as if Brenda has discovered any of these things and or proved them?
Okay, that's a fair question, actually. What qualifies me is the fact why I can say we is because science is the collective property of all mankind. All human beings own science. Science is not owned by scientists or by the elite and the powerful. It is owned by everybody. All of humanity for the last several hundred years, and in fact, to be fair, going all the way back to the Greeks, it is the collective activity of all mankind, and therefore we can all know it. And I can make these claims with confidence because there are other people who back me up. It is not me who is so smart. I stand on the, as we say, on the shoulders of giants. The people come before me who have solved these problems, and that is how I can state with confidence that how I can be assured that what I am saying is correct because other people back me up.
Okay, so from again Ryan, who asks, what is a field and how can it be a particle at the same time? Some definitions, please.
Okay, a field is simply a function that returns a value. And so we imagine that there is a field that is, there are four fields, four fundamental fields. There are some others that they're not fundamental. This simply is spread throughout all of space, and a particle is simply a local disturbance in the field. And the thing about fields is that they are quantized. That is, they can only take specific energy states. So if you input energy into a field and you don't put in enough to create a particle, then no particle will form. It has to be enough energy at a particular level, and then a particle will form. And that is how you create light, by moving charges that will, and they have to be sufficiently energetic to disturb the electromagnetic field and create particles, which are local disturbances of the field. The field is just a concept, and to a certain extent, perhaps we don't know. Perhaps fields are in some way composed of strings. Perhaps string theory explains fields. I don't know, and string theory is not. It is still theoretical and is not a confirmed part of science. So there are many things that we don't know.
Okay, so from Brian Leake, who asks, is a wave what something is, or is it what something does?
It is what something does. It is what the field does. And it is always waving. The electromagnetic field, the various fields, electromagnetic, strong, weak, and nuclear forces, these waves are always moving. They are never at rest. Due to the Heisenberg uncertainty principle, they can never take the value of 0, because if they did, they would cease to exist. So the electromagnetic field is always moving what we call the quantum foam. There is always random, chaotic movement and the creation and annihilation of particles at the very lowest level of reality. But that's what a wave is, a disturbance in the field.
Okay, so we have quite an interesting question here from someone that I've actually never come across before, actually, a lady called Caroline, it looks like. Have yourself read any of Walter Russell's work?
I don't know who Walter Russell is. I'm sorry.
Okay. Right, let me just keep going down the list. From you to Brenda, who pays you to troll, question mark?
Nobody pays me. I do this because I enjoy it. I enjoy talking to flat earthers. I would like to explain things and explain how I understand things to be, and to have them explain to me. I would prefer that we not have emotional discussions and debates. I would prefer that we simply talk about our ideas. But I talk to a lot of people on the internet. I talk to people who are about politics, about philosophy, about other things, and this is what I enjoy. I enjoy it. I have some certain medical issues that constrain what I can do, and also I have I'm not very wealthy. I'm quite unwealthy, as you might say, and so I have free time to pursue something that I enjoy.
Okay, so from Dabbing Good, ask if Brenda believes the speed of light is constant, being we don't live in a vacuum, question mark, and doesn't that kill Einstein's theory?
The speed of light is in a vacuum is constant. The speed of light will change. It's slower in different media. So in the air it's slower, and in water it's slower still. In glass it slows down. That is why a prism can break up light into its component wavelengths, because the different frequencies will travel, will strike the surface of the prism and take different paths and take different angles. So the speed of light is always constant. It doesn't refute Einstein. It is in fact the central idea behind relativity. The central idea behind relativity is that the speed of light is always the speed of light for all observers. Even if you were traveling close to the speed of light, you would still measure the speed of light as it is, as 300,000 meters per second, I think it is.
Okay, so the Rumpus wants to correct you, apparently. He's asked me to say, tell Brenda that light is not, in capital letters, just created by accelerating charges. Electrons jumping between energy levels in an atom is the main, in capital letters, source of light, not accelerating electrons. Would you agree with that?
Okay. Rumpus knows more about these things than I do, so I'll accept that criticism. And I don't mind people criticizing me. I don't mind people correcting me. People can go ahead and do that. I enjoy that, and I welcome it. I encourage it. If I ever say anything that you believe is wrong, correct me and do so, and I will address it. I assume that Rumpus knows more than I do, so I will take that correction.
Okay, so from Croexy again, would it be okay to say that space-time curvature is a disturbance in some field, in brackets quantum field, in a certain way around masses? I can repeat
I guess
the question
so.
if you like.
I'm not sure. I understand the question, but I'm not sure that I know the answer.
Fair enough. Yeah, I mean, I wouldn't pressure anybody to say something if they weren't sure, and I actually would appreciate them when they actually say, "I don't know," because to me that's better for me. I prefer people to be honest like that. So from Daniel, who asks, what do you think about quantum erasers' use of the second law of thermodynamics?
It is a misunderstanding of thermodynamics. I don't think that it is either. I'm not sure if it's deliberate or a misunderstanding, but the second law of thermodynamics simply states that the energy available to do work in any closed, isolated system will decrease over time. There will be less and less energy available to do work. So the presence of pressure in the atmosphere does not conflict with the second law. And why? Because gravity is what is causing the pressure of the atmosphere. You have a column of air above your head that is pressing down on your head at 14 pounds per square inch, and luckily for you, inside your body, the pressure inside your body perfectly opposes that, and so you exist in an equilibrium, and therefore you don't feel any pressure because the two pressures are the same.
Okay, just a quick response to Carl there. Thank you very much. I do try to be unbiased, and this is what this entire platform is about. So, from Super Dave, who asks, why does science keep changing?
Because it keeps improving, because it's an estimate. The first step in the scientific method is make a guess. You can look up Richard Feynman's lectures on YouTube here, and he'll tell you the first step is you make a guess, and then you test that guess. You test it repeatedly. So if I want to know how high how high I need to buy a door for a doorway in my house, how tall does that door need to be? Well, let me guess. It needs to be 7 feet tall. Well, I should probably guess that, but then I should probably test that guess and get out a ruler and see what that measurement is. And so I get out a ruler. Oh, it's actually 7 feet and 3 inches. But maybe I want that to be a good fit, so maybe I need to make yet another measurement and say it's 7 feet 3 inches and 1/16 of an inch. So it's repeated measurements, repeated observations over time are why science changes, because we have we develop hypotheses and theories and test them. Sometimes the hypothesis turns out to be wrong. Sometimes the guess is wrong. Sometimes the guess is close, but we can get closer. So the distance from the Earth to the Sun is 93 million miles. That's a first guess, but that's not the best guess. We can make more and more measurements and get closer and closer to the actual value. That is why science changes.
Okay, so we have a little bit of a statement here from Captain the Game Master, who says, the speed of light doesn't change speed in a different medium, it just takes longer to pass through the medium because the light scatters and travels a further distance. Would you agree with that?
Okay. Yes, I would agree with that.
Okay. Let's say Flat Out Faith, again, thank you very much. That's what I'm trying to do, is get down to the nitty gritty and find out what people believe, why they believe it, and if they can back up their assertions, which, you know, Brenda, you're answering every question. I think you've only passed on one, and to be fair, if you just don't know the question or the answer, just don't even try, because that's when people will jump down your neck if you make things up. So, looking for some more question, guys. Let's see. So, you stating apparently he thinks you're just parroting things.
To a certain degree, I am repeating knowledge that I have gotten from other people. That's nothing wrong with that. I can get knowledge from other people because, as I said, science is the collective wisdom of all mankind. So we can pass knowledge from one person to the next. I don't have to discover fire all by myself. I don't have to reinvent the wheel. I can simply use the wheel that was created by other people. And from that wheel, I can then build something else. I can build a horse cart. And then I can take that horse cart and I can put a steam engine on it. And then I can put a gasoline engine on it or an electric motor on it. And that's how we can get from the wheel to the Tesla by building on the work of other people. There's nothing wrong with that. We are not individuals alone in the world. We are part of a community of people, and science is part of our collective community. It is something we all have, and we should not allow other people to take it away from us and to deny us access to the collective wisdom of mankind.
Okay, so thank you, Super Dave, for the super chat, by the way. A question from Daniel, who asks, what do you think of Quantum Eraser and Nathan's argument when it comes to a rotating sphere that planes should travel much faster one way than the other?
They're just wrong due to the conservation of momentum. The Earth is rotating about its axis, and everything on the Earth and the air above the Earth all has the same angular momentum, and so does the plane. So the plane takes off, it inherits the momentum of the Earth. It exists within that reference frame of the Earth. And so you cannot simply get in a helicopter, levitate, and wait for the Earth to rotate under you, because you are still moving with that Earth.
Okay, so a little statement here from Carl Stenbach again, who says, the universal constant of gravitation, or big G, is still not defined to this very day. It's been estimated all along, and Cavendish used a different value than Newton. Would you agree?
I don't know. Cavendish was not setting out to measure G. He was setting out to measure the weigh the Earth. In the process of doing so, however, he did have to calculate G. I think it was small g. But the Cavendish experiment conclusively shows that mass attracts mass. And there's simply no dispute about that. The Cavendish experiment is repeated by university students in physics classes in thousands of universities around the globe.
Okay, from Brian Leake, who asks kind of like a theoretical question. Can plants grow on the wavelengths of light emitted by fire or fusion?
I'm not sure by fire, but since the sun operates by fission and fusion, then yes, because the sun is a giant ball of hot plasma. The energy is produced by fission and fusion, and that is the light that sustains us. So that's where the energy for life comes from, is from the sun, and from the thermonuclear reactions that are going on in the center of the sun.
Okay, so I'm probably going to take just probably 5 more questions because they still keep piling in, but I don't want to keep you here all day, Brenda.
I have time, but it's up to you.
Okay.
I can stay as long as you need me.
Well, I'm happy to stay as long as the questions keep popping in. So, from Unicorn Laser Eyes, does Brenda think that it's fair to quote a philosophy definition of phenomena when speaking in context of science?
Yes, because science needs philosophy. Science is a result of philosophy. It used to be simply called, it was not called science at one time. It was simply called natural philosophy at one time. Science is simply the application of the philosophy of empiricism and naturalism to the everyday world. So the philosophy of science is important to understanding how science is done. Philosophy cannot judge the outcomes of our experiments, of our empirical observations, but it can undergird and serve as a way of understanding how science is best done. For example, in the 1950s, people like Karl Popper criticized what was then called positivism, which was the belief that you could prove things by science. And now people understand that you can't prove things by science. Scientific theories must be falsifiable. They can't be shown to be true, but they can be shown to be false. So science doesn't actually get us to absolute certainty or proof. It gets us to approximate proof. It is provisional and subject to change. At any time, new experiments or new observations could overthrow everything we know. It seems quite unlikely, extremely unlikely, but it is at least theoretically possible. So we don't have absolute certainty. Certainty is not knowledge. That would be something else I should have covered. Certainty is not knowledge. Certainty is an emotion. It is the feeling that you are right. It's not actually being right.
Okay, so we have a question from Brenda who asks, have you looked into gravimeters, an instrument that measures tiny changes in the gravitational field that we can use in geology, for instance?
No, I have not. I am not an engineer. I'm not educated as an engineer. There are a number of engineers in the globe Earth community who would probably actually know about that, but I don't know about gravimeters. I do know that you can take a weight and measure it at two different places on the Earth and get two different results, and those results comport with our current theories on gravity and on the globe Earth. So flat Earth would need to explain why two different places on Earth get a different weight for the same weight, a different measurement, I mean.
Okay, so from the Rumpus, I think this is more of his statement than a question, but I'll read it anyway. Ask Brenda if she agrees that without forces, the second law would cause all atoms to separate into a homogeneous mush. Forces bring order to the world and also for the atmosphere.
Yeah, I agree with that. Yeah. Yes.
Okay. We had something. Where are we? Okay, so going back to the question about momentum and planes, Brian Leake follows up with, what if a plane spins a few circles? Does it still retain its momentum?
Yeah, it's still within the reference frame of the Earth. There is a great black and white video called Frames of Reference. I think it was produced by MIT back in the 60s. It's a very good look at reference frames, and because it's black and white, it makes it much more clear. So yes, an airplane traveling in circles would still be traveling in circles in that reference frame. Okay. Because everything is still moving with the Earth at that 15 degrees an hour.
From Caveman Smash, Brenda, what are the steps of the scientific method?
They are make an observation, right? Construct a hypothesis, right? Test your hypothesis. Repeat those tests until you are able to come up with a theory. And then the theory can serve as a basis for further observation, further experimental tests, and repeated. It is a process of repeated experimentation and observation. Because some of these things are very difficult, the scientific community has two different sort of job titles. Some people just spend all their time theorizing. They're not making guesses. A theory is not a guess. It is a systematic mathematical concept that is based on those observations. And then you have experimental scientists who, and they are in competition with each other. Experimental scientists love nothing more than to shoot down any theory that the theoretical physicists come up with. And so it is that process of competition. And every scientist, when they have a theory, tries to prove it wrong. If flat earthers want to be considered as a legitimate endeavor, they need to prove themselves wrong, because that is what science does. Every scientist, when they go into the laboratory, wants to prove his theories wrong. It is his failure to prove himself wrong, time after time, that eventually those theories will be written down into textbooks and considered to be a fact.
Okay, so from, I don't know how to say this, XANH, Ahsen or something I think it is, ask Brenda if acceleration is meter per second, which is also gravity's unit, and if the ISS is at free falling speed, then their fall velocity is increasing by the second. What is their velocity?
I don't know what their velocity is. I know that, yes, it is falling. The ISS is falling. The thing is it just keeps missing the Earth. It has a forward momentum that is carrying it around the Earth. And eventually it will fall. If nothing else is done, eventually the ISS would fall and collide with the Earth. However, it is very far up. There is very little friction to slow it down, and so it would take a long time. So the ISS is falling, right? But it also has forward momentum in addition to the acceleration towards the Earth, and that forward momentum means that it keeps missing the Earth.
Shout out to Unicorn Laser Eyes for the super chat. Thank you very much. She says, thanks for your work, Ranty, and thanks, Brenda, for the presentation.
Yes, and $5 is much better than the paltry 99 cents. What the hell is this 99 cent stuff? You can give more than 99 cents, right, Ranty?
No comment.
Well, I can advocate. Ranty is doing really a great thing. He is allowing people, Globers and Flat Earthers, to come on and to give their side of the story uninterrupted, and this is a great thing, a service for him to do. He is to be commended for this, and people ought to reward him for that. Give to his. You have a Patreon page, Ranty?
I do, Brenda. I do.
Yeah, people should give to the Patreon. People should give to the Patreon.
So we have a question from Ryan who says, reference frames, how do you measure the kinetic energy of objects in a moving reference frame? Is it possible?
How do you measure the kinetic energy?
Of objects moving in a reference frame? Is it possible?
I would imagine. You just do it the normal way. You can assume or take a reference frame as being at rest. So if I'm in an elevator in space that is accelerating, or even just accelerating, that would be I can just measure those objects as if I were at rest. If I'm on the spinning, rotating Earth, I can consider my room to be at rest, even though it is actually part of the Earth and is rotating with the Earth at 15 degrees an hour. That is inconsequential. For most of the things I'm going to do in my room to make measurements of kinetic energy, they are not going to be affected by the spin of the Earth. So that's how you can do it.
Okay, from Five Angels, who asks, explain the sun's gravity and why it doesn't attract bodies on this world. Why am I not lighter during the day?
You might be. You would have to calculate. I don't know how to do the math, but it might be that you are lighter when your side of the Earth is facing the sun, as opposed to when your side of the Earth is away from the sun. But that difference needs to be calculated according to the correct formula. And I don't know what that is, but I would be willing to hazard a guess that it is very difficult, very small number, very difficult to measure. So it might be the case that you are your weight or your height is affected, for instance, by the moon. I think I've read somewhere that that is the case, but I don't know how much that would be. I think it would be very small, and I'm not certain that it would actually have any effect on your perception of your weight. I think it would be so tiny that you would not know it.
Okie dokie. Well, it appears that the questions have dried up, and I'm.
That's fine. Thank you very much, Ranty.
No problem. No problem.
This was great. This was great, and thank you very much for allowing me to give a slide presentation instead of a video. I understand that you need to protect your channel, and that's understandable. And I want to thank you for allowing me to present it as I did. I hope I did okay.
It's absolutely fine. And to be fair, I mean, it's like, I'm giving trust into you guys. I've given you the option there to do a live presentation. People are at the other end of the computer, and some people will, we've seen it before, do nasty things to people's channels. So, it's a case of, I'm literally offering my channel and to help you guys out, and I give full trust that you'll respect that and behave accordingly.
I do.
So
yes. Thank you very much.
Right, well, in around about 15 minutes, we're going to do another show. So we're going to get the Adam Meakin on, and he's going to be doing a presentation. But in the meantime, thank you, Brenda, for stopping by. I'm going to round out this stream now. If you want to pop yourself on mute, I'll do the outro. And guys, tune back in 15 minutes' time. Adam Meakin will be on, and he will be doing a presentation, and also he'll be taking your questions too. So hopefully I'll get to see you in around about 15 minutes. Until the next one.